This time, I'll talk about building a fragility classification and a clustering model in Python. Why this fragility classification and the clustering model is so important? First, fragility is undermeasured. No single index captures institutional fragility, conflict, fuel export dependence, and small state vulnerability simultaneously. Secondly, policy requires granular typologies. Aggregate FCS labels hide critical heterogeneity. Clustering segregates fragile only from conflict only from SDS cases, each needing tailored interventions. Thirdly, spillovers are costly and global. Fragility drives refugee flows, trade disruption, and geopolitical instability. Qualifying risk enables proactive international support. Lastly, replicating the IMF's WGI GNI typology in code enables annual refresh, early warning, and a scalable country engagement strategy design. My model is based on this paper. If we take a look at this paper, it is published in 2026, so it is relatively new, and you can see in this paper a lot of content here and also contains a lot of data. This paper is available on the internet, so if you are interested, you can download it and read it by yourself. In my model, first I did data ingestion and performed data cleaning and feature engineering, and I did subgroup labeling, and I use the PCA technology to do this dimensionality reduction. And then I did unsupervised clustering. At the end, I generated outputs and visualized my results. The first step is data ingestion and data cleaning. I captured 5 dimensions of governance quality, control of corruption, government effectiveness, regulatory quality, rule of law, and voice and accountability. And then I use these World Bank World Development Indicators, WDI, and provides key economic metrics including GNI per capita, tax revenues as a share of GDP, government expenditure as a share of GPT, and GDP growth rate. And then I use OECD fragility scores. And I also use this IMF fragile and conflict affected states list. I included binary flags identifying whether a country is classified as fragile or conflict affected, currently experiencing conflict, fuel dependent, or small developing state. Then I did feature engineering. I filled in any missing data use the median value from other countries. I applied a log transformation to GNI per capita to reduce the skew caused by extreme outliers. And then I normalized all variables to a standard scale with a mean of 0 and a standard deviation of 1. And lastly, I created a combined governance score by averaging 5 of the 6 WGI dimensions. Next step, I assigned each country to a 1 of 8 canonical subgroups per IMF Tables 1 logic. My priority order is like this: fuel, FCS, then conflict and fragile, then SDS, FCS, and then fragile only. And remaining LICs split into marginal, low fragility by WGI threshold. Non-FCS EMs assigned as baseline comparator group. And then I did dimensionality reduction with PCA. The first principal component captures about 50% variance. And the second component captures about 22% variance. So if we combine those two, it will explain about 72% variance. That's pretty good result. And I also loaded errors review which features drive fragility clusters. Then I used the k-mean clustering with 6 groups and 20 initialization attempts to uncover natural fragility patterns directed from the data. Then applied agglomerative clustering with word linkage to organize countries into a meaningful hierarchy of risk groups. I projected cluster centers into PCA space to make the groupings easier to visualize and interpret. Then I cross-checked data-driven clusters against rule-based subgroups to confirm the results hold up. There is a figure 3 in the paper I mentioned before. I recreated figure 3 as a scatter plot comparing governance scores against income level. I'll show the detailed result later. Also, I generated the PCA biplot showing how each indicator pulls on the components, making the model more explainable. I mapped k-means cluster in 2D PCA space with centroid marked for clear view of how groups separate. Lastly, I produced a bar chart of median indicator broken down by fragility subgroups alongside a CSV export of country level results. Okay, now let's go to my Python model to run the model and generate those results. Okay, this is my Python model. First, I have this country's data as input. You see, I have all those countries' name, WGI, GNI, all those data, and I have the flag if it's conflict or fuel or SDS, and then I will load the data here, and this function will label all the countries. As I mentioned before, I will prepare data frame, assign fragility subgroup labels, and this section I will do the PCA and the k-mean clustering, and here I'll do the visualization. You see this first plot, and second one, and third one, and fourth one. Lastly, I'll export all the data from my model into CSV file. I will upload my Python model into my GitHub so you can download, and maybe you can modify all those data and try to run it by yourself. Now let's run our model. You see, I generated 4 graphs here. If we take a look at them one by one, this is my first graph. The plot visualizes the relationship between fragility intensity measured by WGI and income level measured by GNI per capita is in the log scale. You see, this x-axis measures governance quality and stability. More negative scores indicate weaker governance or higher fragility. And this y-axis represents the country's income level. Higher the value means higher per capita income. Each point represents a country. Color and shape coded by fragility subgroups. You can see the labels here. So you can see there is a general negative correlation. Higher fragility, lower income, but with notable exceptions. The figure can be used for policy targeting, showing which countries are fragile despite higher income or extremely poor and fragile. This plot is a PCA, principal component analysis, by plot showing countries' positions and feature loadings. X-axis PC1 explains 49.6% of variance, and y-axis PC2 explains 21.7% of variance. Together, the first two principal components explain over 71% of total variance, giving a good summary of the data set. Each point represents a country, colored and shaped according to its fragility subgroup. You can see PC1 mainly separates richer, better governed countries from poor, fragile conflict countries. PC2 separates high GDP growth countries from low GDP growth or high fragility countries. The plot reviews clusters of countries by economic and fragility characteristics, showing how governance, income, and fiscal indicators contribute to differences. Now, let's take a look at this k-means clustering. The plot shows k-means clustering, k equal to 6, so there are 6 clusters here in PCA space, meaning the original multidimensional fragility data has been reduced to 2 principal components, PC1 and PC2, for visualization. Star indicates the centroids of each of the 6 clusters. Again, you can see PC1 explains about 49.6% of the variance of the data. PC2 explains 21.7% of the variance. Together, PC1 and PC2 captures more than 71% of the total variance, giving a reasonable 2D approximation of multidimensional structure. PCA reduces dimensionality so we can visually identify patterns and clusters. K-means identifies group of countries with similar fragility profiles, useful for policy analysis, resource allocation, or risk assessment. Now, we come to the last graph of my model. The chart shows median economic indicators by fragility subgroup with tax versus GDP scales down by 5 for readability. The x-axis compose 8 fragility subgroups. You can see the label here. And y-axis shows the median value. Display the red bar is WGI score, and the blue bar is tax versus GDP divided by 5, and the green bar is GDP growth displayed by percentage. You can see all fragile subgroups have negative WGI score, reflecting weaker governance. The least negative values appears in low fragile and non-FCS group. You see here, indicating better governance. The most negative score are in few FCS here and conflict and fragile here, suggesting severe governance issues. Fragility is associated with lower governance scores, lower tax revenues, and variable GDP growth. The chart highlights the economic constraints faced by more fragile states, especially those dependent on fuel or affected by conflict. This is how I built a fragility classification and clustering model in Python. Please comment, like, and subscribe to my YouTube channel. Thank you for watching.